Hello everyone, and welcome to this latest PV Tech Talk product series webinar. This is Mark Osborne, Senior News Editor at PV Tech, and I'll be moderating this half-hour webinar and 10-minute Q&A session with FuturaSun, which is launching its high-efficiency N-type mono IBC cell-based ZEBRA solar panel to the European market. Our speakers today will be Alessandro Barin, the CEO of FuturaSun, and Lisa Vernon, who is the sales engineer at FuturaSun. Just a reminder, please, that as usual, feel free to post questions throughout this webinar for the Q&A session at the end. And we also have FuturaSun staff to help answer any questions you may have. That's it from me until the Q&A session at the end, and I'll hand over to Alessandro to start this presentation. Thank you, Alessandro, yours.
Hello, Mark. Thank you for having us. I'm very honored to be here today to talk about FuturaSun and our new ZEBRA panel. Let me give you a short introduction. Our story goes back to when the PV industry in Italy was about to crash because of the sudden change in support policies for the PV sector. I'm sure you remember about that. It was then that a group of PV experts from the Venetian region of Italy came together and decided to combine their knowledge in PV with the dynamism of the Chinese supply chain at the time. I myself already been living in China for 10 years, and together we started building FuturaSun brand and business, which is now active in almost 70 countries around the world, with hundreds of megawatts produced every year. Early on, when we started out as a PV panel supplier, we relied exclusively on our suppliers' capacity. However, we knew from the beginning that someday we would set up our own manufacturing plant. Well, you see, we come all from a manufacturing background, and at some point, that dream had to come true. So 3 years ago, we built from the ground up what was going to become the first and only Italian solar panel manufacturer in China, reaching a production capacity of 1 gigawatt. Well, looking at the products, well, for over 10 years, our company has been active in the production and sales of P-type solar panels, starting first with the polycrystalline panels, and then from 2015, shifting our sales focus to monocrystalline panels, and more specifically to PERT technology. The market in Europe for FuturaSun has been great this year, and the demand is strong also in China. But again, it is almost all about P-type solar panels. P-type has grown to become a mature and cost-effective product. We cannot deny that. In the market, it has the most competitive price, closing the gap in with the poly panel. And it is the most widespread solar type in the market today. However, there are still limits to what this technology can bring. While we, the FuturaSun, we want to take a look at what the future might be like. And trying to anticipate what the market will demand in the years to come. And that's what we were going to talk about here today. We wish to stress the importance of how to increase electricity production per kilowatt installed. We want to decrease the temperature coefficient of the solar module. And we want to show you a great looking panel. Trust me, when you see our ZEBRA IBC panel to you, you will be blown away. It is so awesome, both the silver and in the black versions. Look at them, they're so beautiful. But to delve into the details of our ZEBRA panel, I want you to talk to Lisa. So let me introduce Lisa to you. There you go, Lisa.
So thank you, Alessandro. First of all, I would like to thank all of you for joining our webinar today. My name is Lisa Hirvonen, and I'm here today to present the ZEBRA model more in detail, a little bit more from a technical point of view. So I would like to start with just some fun history. In 1969, a new era was marked with the first moon landing. But actually already 15 years earlier, the New York Times talked about a different era, the era of the solar industry. The very first solar cell made of silicon actually was an N-type back contact solar cell. So today we can say that we are returning to the original of using N-type wafers that is the basis of the ZEBRA panel. The N-type ZEBRA technology is giving several important benefits, and this is what we are here to talk about today. The ZEBRA model is based on the European cell technology ZEBRA, developed by the International Solar Energy Research Center Constance. The ZEBRA cell is a back contact solar cell, meaning that both the positive and negative contacts are both on the back of the cell, leaving a completely clean front. On this slide, you can see the photo of the cell, or an illustration of the cell. So on your left, you can see the front side of the cell, and to your right, you can see the back side of the cell. The ZEBRA cell that is based on an N-type wafer reaches an industry-leading efficiency of 23.5%, so much higher than most cells currently available on the market. The ZEBRA series, as you can see on top of the slide, is available with white backsheet with a power range from 350 to 360 watt peak, and in the very elegant version total black with a power range from 340 to 350 watt peak. You can see a photo of the black version on your right side. Coming to the power, as you can see written on the slide, once the cell is transformed into a model, the high efficiency remains, reaching almost 21.3%, so translating into more energy on less space. So here we can say that we already have a very first benefit for the residential market where space often is an issue. In both versions, the frame is always black for a superior aesthetical appearance. Here you can see the solar cell, and as the name says, the electrical contacts are on the back, creating a completely plain surface. So thanks to this, we don't have any shades on the cell caused by ribbons or bus bars that you can see on the standard mono cell on your left. The ZEBRA cell has also maximum light absorption, because the front side is completely clean. We don't have anything covering it. And this is, of course, also creating a very nice aesthetical appearance of the cell itself. Here you can see the size of the panel. And as you can tell from the illustration, we are not going crazy sizing. In fact, the dimension of the ZEBRA panel is comparable to a standard 60-cell panel, making it easy to handle for the installer when he's on the rooftop. So, meaning that we have an industry-leading model efficiency on a very compact model size, measuring a width of 1 meter times a height of 1.68 meters, with a weight of only 19.5 kilograms. Lately, we are seeing new panels being launched on the market with bigger and bigger sizing. But these panels are, according to us, maybe more utility scale oriented, so they are excluding the residential segment. So for the residential market, we can say that the ZEBRA panel becomes a winning card with its compact size and very high power. So coming to a little bit more technical benefits of the ZEBRA panel, we will start with its more stable performance with time. Actually, 95% of the cells worldwide suffer from a phenomenon called LID, that is short for light-induced degradation. And this degradation occurs during the very first period of sun exposure that can cause a reduction in efficiency all the way up to 5%. Another important degradation issue is LITID, and this combines the effect of light with the effect of high temperatures. And also this can be really devastating for the panel because you can generate power losses all the way up to 6%. And P-type cells that are used for all standard panels, including PERC panels, are doped with boron, and this is the main cause of these degradation issues. But the ZEBRA panel, by design, it's immune to degradation problems like LID and LITID, because the cells are doped with phosphorus. And coming to UV rays, these are not only aging our skin, but they're also very harmful to many other materials, including solar cells. But also regarding this topic, the ZEBRA cells do not degrade under UV radiation. On this slide, you can see the model configuration, and the ZEBRA model is in fact the only IBC model available with half-cut cells, assembled together what we can call a twin model configuration, in which the solar cells are connected in series in two independent sections that are connected in parallel in the middle with a three-part junction box. You might recall that the standard panel with full-size cell has the junction box in the upper center part of the glass and not in the middle like the ZEBRA panel. And having two independent model sections helps, of course, to resolve a typical problem of residential installation, that is shading. I would say that the illustration on this slide is quite self-explaining, because in case half of the model is shaded by a chimney, trees, or similar, the second half will in any case continue to produce energy undisturbed, because the bypass diodes will not bypass the entire panel. This simplifies, of course, the design of installation and minimize also the need of optimizers. So it helps you to save also some costs. So remaining in the theme of shading, the ZEBRA panel demonstrates also its good performance under partial shaded conditions. And to demonstrate this, we did a test to simulate the model performance in case of partial shading created by a leaf. So the same test was done both on a ZEBRA panel as well as on a PERC panel, and both panels had a half-cut model configuration. If you look at the photo, you can see some red dots, and those red dots are where we position the leaf. And in the table below, you can see how many cells that were shaded on the different positions. So, for example, if you look at point number 6, that is in the center of the panel, the ZEBRA had a loss of 8.4%, and the PERC model had a loss of 13.4% with 2 shaded cells. So, moving downwards on the photo to point number 7, you can see a loss of 0.24% for the ZEBRA panel, so a very low loss, while the PERC loss was 8.59%, and this test was done with 4 shaded cells. So I think that we can see the superior performance of the ZEBRA panel at this test. A risk that is related to partial shading is the hotspot risk, which I hope you haven't already experienced. Also regarding this topic, the ZEBRA cell has an important benefit as it dissipates in reverse bias condition, meaning the circumstances when a hotspot occurs. The cell dissipates the heat over a larger area, and therefore the cell stays at a lower temperature, minimizing the risk of damaging the panel. On the left, you can see the ZEBRA cell being stressed under reverse bias, and you can notice how the temperature is dissipating over a larger area. So the peak temperature is not localized. On the right, you can see a thermal photo of a standard cell, where you can notice that the heat is very localized in singular points, and the heat is not moving from its location. So coming to the ZEBRA's behavior in case of low light conditions, and starting with the sunlight. The sunlight is composed by different colors, the colors of the rainbow, and these colors are traveling on different wavelengths. The ZEBRA panel can absorb more light at every wavelength thanks to the unshaded front of the cell. But the biggest differences, as you can see in the graph on this slide, are noticed during cloudy days when the light is shifted to blue, as you can see on the left side, and in the mornings and evenings when the light is shifted to red, that is shown on your right side. This benefit translates to a higher output and longer duration, or said with even easier words, the inverter switches on early in the morning and it switches off later in the evening. This is a slide that I found very important because it explains the difference between how a model is tested and how a model actually is behaving once it's installed. So on the left on this slide, you can find the STC test, and on the right, the real outdoor behavior of the panel. Photovoltaic models are tested in STC, that is short for standard test conditions, and all factories and laboratories worldwide are testing the panels in the same conditions to have an equal comparison of products, which is of course a very good thing. But this test is performed with the light perfectly perpendicular to the model, with an irradiation level of 1000 watt per square meter, a spectrum of 1.5, and with a cell temperature of 25 degrees. And now, if we look at the illustration on your right side, I think it becomes quite immediately obvious that STC conditions rarely repeats once the panel is installed because of various tilts, of course, various tilts on our roof, temperatures, and also irradiation levels that change during the day, but also during the year. And unfortunately, priority is often given to the peak power of the model that is written on the label, a value that is tested in STC conditions. But so what we would say is of even greater importance is the production of the panel expressed in terms of kilowatt hours. And a high watt peak value is not automatically translated to a high kilowatt hour value. So we can say that the high kilowatt hour value can be defined according to how well the model performs in conditions that not are corresponding to the standard test conditions STC. To check that zebra panels' behavior at different tilts, we did a test in STC, but we changed the model tilt to different angles, like you can see on this slide, 5, 10, 15, 20, and 25 degrees. In this illustration, angle 0 is corresponding to STC, so meaning the light is perfectly perpendicular to the panel. For example, at 10 degrees angle, you notice a difference of a little bit more than 2% between the zebra and the PERC panel, which can of course sound like a low number, but if we consider this percentage over the year, we will again gain additional kilowatt hour per kilowatt peak. So during this test, the zebra panel responded better than the model tested with PERC cells. So again, we have an indication that the zebra panel will have an improved kilowatt hour production also thanks to this. Coming to the temperature, also the temperature is a very important factor regarding a good or bad performance in terms of kilowatt hours. A solar model can be associated a little bit with ourselves because also we tend to get lazier with increasing temperatures, and so is the model. The warmer it is, the worse the model will perform, and this performance decrease is defined by temperature coefficient, meaning the lower the temperature coefficient, the better the performance at high temperatures. Our zebra panel has an excellent temperature coefficient of only minus 0.3% per every degree over 25 degrees. So we can say that this is adding circa 3% of power in average operating conditions. Leaving the technical part behind, we are coming to the financial part of this presentation, because IBC panels are what many users call a high-end product. And we all know that everything that is high-end is often also associated and priced at a higher level. And I'm not hiding that so is the case also for the zebra panel, even though it is more cost competitive against other IBC panels available on the market. So yes, the zebra panel is more costly, but surely you will bring home more added value. So we did a graph where you can see a simulation of a residential installation in northern Italy. Here you can find the cumulative financial gain over time using the zebra panel. As you can see, we will have an initial higher cost compared to a system with a standard PERC panel, but thanks to the superior performance of the zebra panel, this extra cost will be paid back. And with time, the cumulative financial gain will only increase. We have stopped this curve at the 25th year, reaching an cumulative financial gain of 1,756 euro. And we have stopped the graph at the 25th year because this is also the year when the warranty expires. But of course, we expect an increasing curve also after this year, because of course the panel will not stop working when the warranty expires. This we all know. So, considering the same 5 kilowatt residential installation in northern Italy, and here we can see a simulation of the kilowatt hour production during the warranty period. So here, please keep your eyes on the blue line that is the zebra performance. And also in this graph, we can see an increasing gap that is reaching more than 8% at the 25th year. The zebra panel has many technical benefits that are translating into high reliability and stability over time with more kilowatt hour per kilowatt peak. But the panel is also characterized by superior aesthetical appearance, making the panel the ideal choice for residential rooftops. Also, availability of the product is not a problem, as you can find a zebra panel available on stock in Europe. So during this webinar, we have mentioned the zebra panel's many benefits. So I'm now asking, is there more to come? And the answer is yes, because the zebra panel has another important benefit that we haven't mentioned yet. And this benefit is that the zebra panel is the only IBC cell that also is bifacial. So yeah, please stay tuned with FuturaSun to know more about this upcoming bifacial zebra panel. So I have finished my presentation. So to summarize this presentation, we can say that the many nice benefits of the zebra panel make us confident to improve also the product and performance warranty of the panel. So the standard Zebra warranty includes a 25 years product warranty and a 25 years performance warranty with an 89% guaranteed power at the 25th year. So I have finished my presentation, and I really hope that you found this presentation interesting, because now we are really looking forward to answering your questions. So thank you all for listening, and I give the word back to Mark. Thank you again.
Well, thank you for this presentation. We just have a short time for a Q&A session today, but for those attending, don't forget the platform is still going to be open for any further questions you may have for FuturaSun. So the first question for you, Lisa, what are the best conditions or installation environments that are best for Zebra panels?
Well, during our presentation, we spoke about the residential market, and yeah, we would say that ideal conditions for the Zebra panel is when you have a limited surface or a defined surface, and of course, when you want to maximize the peak power. So mainly targeting the residential market. And then, of course, also when you want to maximize the aesthetical appearance of the system, because of course, as we see that the Zebra panel is a very nice looking panel.
Okay. Delving into a little bit of a technical question here, and you briefly mentioned this in the presentation, but you claim, so no degradation under UV, but this hasn't really been investigated that deeply, has it? In the industry. So, can you just explain a little bit more about that?
Well, actually, extensive independent lab tests show that the Zebra cell does not degrade when it's subjected to UV soaking. And also, if we look at the panel on panel level regarding the bill of material, also we are using POA, which is more resistant to UV than EVA. So overall, we have a very UV resistant model.
Okay, that's understandable. Okay, staying with with an element of this, and we get this a lot with the presentations that we have. But is there going to be a glass module available?
Yes, or it will be available soon, because the planned bifacial version will be a glass panel. So the Zebra panel will be available also in a glass configuration, but with a bifacial cell. Okay,
just sticking with that a little bit, just give us an update on the general availability of the Zebra panel.
Well, as I mentioned during the presentation, the Zebra panels are currently available in Europe, both with white back sheet as well as in the total back version. So, of course, if you have an inquiry, please don't hesitate to contact us.
Okay. You spent some time, understandably, on things like PID issue, but a question here is really saying, have you got, is the Zebra module PID certified?
Well, actually, the certification is ongoing, but in any case, of course, the product and performance warranty are, of course, in any case valid. And also talking again about the bill of material of the Zebra panel, it is also, of course, proven to be PID resistant. So we don't have any doubts that we will have issues passing the certification procedure regarding the PID certification. Okay, all right.
Well, the next question I've got to throw at you really is mainly comes up for utility scale projects, but I thought I'd ask. This is regarding PAN files in pvsyst. Are these actually available with the Zebra panel?
Yes, and also I agree with you. This question is a little bit more like utility oriented, or a little bit for commercial roofs, but the answer is yes. Also, of course, if you want to use the Zebra panel for a commercial roof, no issue. For a residential roof, of course, no issue. And if you want to do a simulation in pvsyst, you will find all the data already in the latest update of the pvsyst database. So, of course, feel free to make any simulation. Okay, great.
Power optimizers. Now, this comes up a lot as to whether, and I'm paraphrasing here, there's several questions about this, but let's just ask you it this way: are power optimizers actually necessary, or is it like an optional thing?
Well, power optimizers are not necessary for the installation of the Zebra panel, but of course they are allowed. So if you want to use the optimizer, you're free to use them. But we would like to point out that the half-cut model configuration, the design of the IBC itself, and some other features of the model have been chosen in order to obtain the best possible performance in terms of kilowatt-hour per kilowatt peak, and also regarding the overall DC efficiency, so regardless of the characteristic of the connected system. So again, yes, we don't feel that it's necessary that you need optimizers, but of course, if you want to use them, feel free to do so.
Yeah, okay. And of course, we've got the issue that a lot of power optimizers now are not just handling one module at a time, it's multiple. So that's reducing the system costs because of the technology developments in that area. So, okay, moving on. This question here, do you have third-party comparisons for the Zebra panel?
Well, actually, also this is an interesting question, because actually a comparative long-term exposure test is currently ongoing. It's being performed, and this test actually goes beyond the requirements of the IEC 61215-730 certification. And we are expecting to see some nice results early next year, so in Q1 2021. So again, please stay tuned with us, and we will surely share you also these results if you are interested.
Okay. Quite an easy one, I think, here, but it's worth mentioning that it's been raised. What is the system voltage for the Zebra panel?
Actually, the system voltage is 1,500. So of course, quite high for if we are talking about a residential product. But of course, the models can be used also with 1,000 volts systems. Of course, it's not a problem, whatever you prefer. But it is certified all the way up to 1,500. And this is the standard voltage of the panel.
Right. Okay. Cool. Now, you mentioned this right at the beginning, and I think this has been a popular thing for people to ask questions about. Let me paraphrase. Do you have a long-term technology like roadmap agreement with ISC Constants?
Well, we can say that we are working very closely with ISC Constants to improve this very nice Zebra technology also at model level. Of course, ISC Constants, they have done a great job creating the fantastic Zebra cell. And now we are collaborating with them also to continue the improvement also on model level. So all small details giving us more kilowatt-hour per kilowatt peak, like working on the bill of material and so on. So yes, we are in very good relationship with the ISC Constants. Okay,
good, thank you. Well, one that's actually quite close to us, we've worked with this company, and we report about their module reliability findings. The question here is, are you having the Zebra modules tested by Pevel, their US-based third-party testing house, with the Zebra model?
Well, we are considering this because we think that it's a very valuable report, especially for the US market. But of course, this will also depend a little bit on the US market policy regarding photovoltaic manufacturing in China. That currently is not very encouraging, because as Alessandro told you during his presentation, our manufacturing plant is in China. So it will, of course, it depends a little bit also on this topic, how the US policy towards the Chinese market product will evolve during next year. But of course, it's something that we are considering, and we are already in contact with PVL for updates.
Okay, probably got. I'll try and squeeze in a couple of quick questions at the end, looking at the time. Yeah, a good one here. Do Zebra modules outperform IBC modules? Is the question.
Well, actually, the Zebra panel is an IBC panel. And we are targeting, of course, to be in the same performance range of other IBC players, adding also, of course, some extra benefits that the Zebra panel brings us. So yes, the answer is yes.
Okay.
Outperforming IBC models, because the Zebra panel is an IBC model.
Got it. Yep. Okay, last question for you. Are the SDC power figures expected to increase?
Yes. We cannot disclose actually further info at the moment, but the power is going to increase. But actually, when launching this panel, the peak power wasn't our main concern, as we focus more on the energy yield in terms of kilowatt hours per kilowatt peak. Because as I mentioned also during the presentation, we find this parameter more important than the watt power, than the peak power of the model. So yeah, I think
okay.
that answered your question.
Well, good. Well, yeah, well, we've come to the end. Thank you for everyone. Thank you, Lisa, for your time today, and hope to see you back again. So that's the end of this webinar. Thank you. Bye-bye.
Thank you.